Here we go. Welcome back, everybody. I feel like I should have a theme song or like a catchphrase at the beginning, like some of the YouTube channels. Anyways, we are looking at cosine law today, which is another tool, mathematical process that you can use for working with non-right triangles. So for keeping track, right triangles, we started with the Pythagorean theorem, sine, cosine, tan. Then we started to work with non-right triangles by being able to compare two triangles. If you had information combinations between two triangles that were similar or congruent, that allowed you to get unknown values. Now we are, in the previous lessons, obviously just recently we did sine law. And so if you have the right combination of information, you're able to determine values in a non-right triangle. Oddly enough, still using sine, cosine, tan, even though sine, cosine, tan, was from right triangles. So we're going to continue that today with cosine law. All right. So a cosine law is a little easier to sort of justify, not proving it, but just sort of justifying some of the logic of how it works. Sine law, we just looked at the numbers and said, hey, look, we've got something that's the same. So the ratios are the same, so you can use them. But cosine law, I want to show you sort of a comparison here, right? You've got a right triangle on the left. And so you would have, your typical this square here, so this is a squared, and this is b squared, and this would be the the c squared. And so of course, the a squared plus b squared equals c squared, or whatever letters you're using. We know that's true, it makes sense. What we're looking at now is if we take this perpendicular side and we rotate it around, what would happen? Right, so as this thing rotates around like that, what's happening is it's staying the same length. This is staying the same length here, and this is staying the same length here, like that. So as a result, you can picture that this blue side is stretching, right? So the blue side, stretched out from like maybe there or whatever out to this like new distance, so it got bigger, right? So it's bigger. So now if you're looking at a squared plus b squared, obviously that same relationship is not going to be true anymore, right? So a squared plus b squared in comparison to, I don't want to say equals yet, but comparison to this c squared, this new c squared, right? New c squared is bigger. So you can tell that this isn't really equal anymore, right? So it's basically, you have to sort of deal with that basically if you want to use it, right? So this is not equal anymore, right? It's bigger. So cosine law is going to use that, right? So what you're going to have is you're going to have I did different letters that time, but you're going to have like subtract something to fix that. So I'll go back to this one. Basically, if you had this bigger, then you could get a new version where you're going to have like a squared plus b squared, and it'll be equal to c squared as long as you get rid of something, right? So c squared. Yeah, basically it's actually going to be on the other side, but you'll see how it works in a second, right? So take away some value, at least anyways, to make it be the same size, right? So I'm going to show you the cosine law, and we'll make sense of it here, right? So it looks a little weird, actually, the modification when I say take a little bit away from it and so on. On the other side, like if you think about this situation, this one's the bigger one, right? That's bigger than it used to be, right? And so really you'd have to be adding something over here in order to make the b squared plus c squared equal that new bigger a squared. Okay. And the modification that you're going to see in the formula, it looks like we're taking away something, but the way the numbers work out, it actually is this part here ends up being a negative number. Because they have a negative of a negative, and so it becomes actually an add. So don't worry about the number details. It'll just work when you're doing questions. But that's basically what cosine law is. It is what cosine law is. It's just a pattern where it's the Pythagorean theorem with this sort of correction for this changed area of a square because it's not a right triangle. Okay, And so we're going to build the other two. So there's going to be a B squared version and a C squared version. And I'm going to build those with you so you can see what the pattern is. Okay. So first thing I want to point out, obviously there's the Pythagorean theorem, but I want to point out first the idea that we're always going to have side and opposite angle. Okay. So look at A and little a, right? You're going to have over here cosine of like the opposite angle over here. So there's going to be an angle, call it angle. And over here you have the opposite side. Right? That's always going to be true. And that's going to be your focus when you do this. If you're looking at trying to get a, for example, you're going to start with a squared. And then over on the other way, on the other end, you're going to have a cosine of a. That's how sort of how it's going to work. Okay. And so here, if I had b squared, way over here, I would have cosine of b. And if I had c squared, I would have cosine of c. And so that's easy to sort of enter in as a routine process. The other part that's pretty obvious as well is that you have the Pythagorean theorem here, right? So this is the Pythagorean theorem. Whatever Pythagorean theorem basically format. And whatever you have in the first part, this part becomes the other letters, the other sides. So I'll squeeze that in there, the other sides, right? So that down, make that possible. So it's Pythagorean theorem with the other sides matched up. So if you have a B here, then there must be an A and a C, right? So A squared, C squared. If it's C, there must be an A and an E. And the order won't matter there, of course. Okay, so there's the other two versions so far. And then we're always going to have a subtract, so subtract stuff, right? And it is always going to be, if you notice, same two sides again. So BC, BC, AC, it's going to be AC. AB is going to be AB. Okay, so we're going to have the two AC in this case, and we're going to have the two AB in this case. Hope I didn't say that wrong earlier. AB and AB. All right, so those are the three versions of cosine law. You really only need to memorize like the pattern, right? So cosine law, based on Pythagorean theorem, is this, right? Where you know, like we said, this is side and opposite angle. And then really you just have other sides and other sides again. Thinking of it like this just makes it so much easier to deal with. Okay. So what I would say for using it easiest is if you don't have a crisscross, right? So I would say when you use it, I would say, well, it's not a 90-degree triangle, right? Not a 90-degree triangle. And B, there's no crisscross of information. That's the easiest way to do this, right? If there's crisscross of information, you can use sine law. If there isn't, then you're just going to use cosine law, right? So I've already done this a little bit, the how to use it part, and basically it revolves around, if you're looking for, if you have an angle and you're looking for the opposite side, that's amazing, right? Because then you're say you're looking for this and you know the opposite angle, then great. And in that scenario, you would know the other sides. Okay. I want to say about that. Let me go back to my old version, right? So yeah, if you're given an angle, right, then write the version with that angle in it. And if you're asked for an angle, write the version with that angle in it. So it's just basically whether the angle is known or not, right? So if you're given one angle, like sometimes you're given more than one and so on. So you get practice with it. Good at deciding how you're going to go about it here, but I would say this is a pretty good way to start out, right? So the information I've given you so far. So yeah, if you're given an angle and it's pretty obvious you're going to need to use it, well then write the version of the cosine law with that angle in it, and then everything else has to fit relative to it, opposite sides and other sides in the right spots. And same thing if you're asked for the angle, write it. Just if you're given the angle, you're writing the number. And if you're asked for the angle, you're writing the letter in, right? So let's try it here. Write this down, press pause in the video, write it down, try it. This would be the best way to really learn this rather than just watching. But I just let you do what you need to do, right? So when you set this up here, you might look at this and say, okay, let's go here. I've got a side and an opposite angle as a start, so for a crisscross. But then you're like, oh man, I don't have this angle and I don't have that angle, so I really don't have another crisscross, right? So you're saying there's no 90 degree, right? And there's no crisscross of information where you have the crisscross information would be if you were looking for one thing, but you have everything else. And that's not possible. But what is possible is a cosine law. So you're going to use this thing. And so I would just start with, way on the other end here, a cos of 55, right? And so you're thinking of it as a cos or a cosine law, where you just fill in the blanks, right? So what we said already was you have an angle here, and of course, way over here to the opposite side. So that's going to be your B, right? So opposite side. And then the other letters, right? The other letters, so you could write them in as A and C if you want, or you can just put them as 15 and 9, right? 15 squared, 9 squared. Then it's going to be 15 and 9 again. So brackets are necessary here, otherwise it looks like 2,100, whatever, right? 159, so it's 2 times 15 times 9. Yeah, so then you just run some numbers here. So I've got set up where I can show this now as part of the lessons. I'm going to do that from now on, and I have some videos that I've put in for you to show the stuff that I've missed doing earlier. But so if you need help with calculator work, it's there for you. So here we go. If you're calculating all this stuff, you're going to do your 15, and so that looks like this on this calculator. 15 to the power of 2, you know, gives you the 225. You may have known that one, anyways. I'll certainly show the calculator stuff when we get to the sine cos or cos version of stuff here. So 9 squared is the 81, and I have the 2 times the I have the clear that stuff. So I'll just show the 9 squared there to confirm that one for you. The 2 times the 15 times the 9. That needs calculation-wise to be done first. And we have to recognize it's a bad math thing, right? And multiplication, division, and whatnot. Do that thing, get that number. Was 270. 270 cos of 55. Definitely some algebra steps to watch for here. So b squared equals all that stuff. So you need to do that. You know, you can't. Well, anyways, you have to do that. A bigger thing to watch for is actually that cannot subtract these guys, right? You can't do this. Be like, no, don't do it, right? Because you don't have just 270. You have 270 times cos of 55. That's a bigger one. So that first for sure. Let's do the 225 plus the 81, just to save our brains here. We'll just do 225 plus the 81 gives us 306. We have 306 take away the 270 times the cos 55. Okay, so definitely have to make sure to do this stuff, right, as a number, right? Not, I'm going to put here, not 306 take away 270, right? You have to get the 270 times the cos 55. So we have the 270 times, in this calculator, cos of 55. And I can check to make sure I'm in degrees here, hit mode, see it says degrees, we're good to go, clear that. 270 times cos of 55 is 154.86, right? So if you had to subtract 270 from 306, you would have been subtracting too much. You only actually 154.8656 ... 154 0.865. Try to decide what to write here. 865. I just don't want to look like I haven't rounded properly, right? So I'm just going to say 86 dot dot dot. So it keeps the decimals. Of course, I'm all of it calculated because I can do that. I'll show you. Then I'll show the other calculator version. So this calculator I'm using is a direct algebraic logic type calculator. You might have one like that. And then I'll show the other one for sure, because when you put your phone sideways, it doesn't work quite like this. You might have noticed. So here we're going to do 306, take away that answer. So I'm going to do a second function answer. So I'm going to do 306, take away that 154 number. Give me this number. Square equals 151.13 dot dot. 1.13 dot dot. Now, I'm going to get rid of that square by moving, right? So I'm going to get b equals, now we don't typically talk about the plus or minus, we're talking about the lengths of sides of a triangle, right? So it's going to be positive, it's a length. It's just a value, it's just a length. You don't measure something to be negative. It's you have like directions involved in concept. So anyways, here we're going to do root of the 151. So I'm going to just say, my root button here, second, and then the square function's doing the root, and I'm going to do up the answer. And enter. So 12.29, so I'm just going to say 12.3. Okay, so that is your answer here. It's the length is 12.3. Okay, so solve for a side. Yeah, solving for a side or whatever. So I solved for B. Obviously, we could keep going, solve the rest of the thing, but I think all I was going for in this question was getting B, right? Once we have B, then I suppose we could use sine law to get angle C, and then and so on and so on. Keep going and solve most of the triangle, but the new work done, right? So I will also show the non-direct algebraic logic, kind of old school calculator version of things. So what that would look like here, we'd have to do the cos of 55. Let's, I guess, do the 2 times the 15, but that's not the hard part. But 2 times the 15 times the 9 gives, of course, the 270. Then we have to do the 270 times the cosine of 50, and that looks a little different here, right? Because we do 270, and then times, you have to hit 55 first, do cosine of it, and now it's ready. It's actually showing it, at least in direct algebraic logic, but it makes you type it in the old school way where you hit the angle first and then boom, do cosine of it. So now if I actually say, okay, this number here, the 0.57, is just the actual cos, it's kind of misleading, okay? But when you hit enter, it's actually going to multiply the 270 times that number. So that's the 154. Answer button on this. I guess I could do this. I could hit IM plus, and then that stores that number in memory. So then I could do 306, take away memory recall, and hit enter, and that did the subtraction for me without having to write down a bunch of numbers. It's keeping a couple extra decimals for you. Then we need to do root of that stuff. So let's do memory plus again, and then do root of that answer. And boom. See what did I do there? Did I not do that right? So I want to say, oh, you know what? It's the direct algebraic logic thing coming in again. I need to have answer, and then boom, do the root of it. And that gives me the, so it's doing even the root in old school version, right? Where you hit the number in, and then you do the root of it, right? So put the number in and then push the button, and it just gives you the answer. But it shows it in direct algebraic logic up here, root of 151. It doesn't prompt you to type it in that way. So the preference, most modern calculators, lots of modern calculators, are this way, where you do cosine, you hit cos, and then you divide, and then you enter. But iPhones, so you gotta let Apple know that it would be better if the iPhone worked in a better way. Direct algebraic logic is just sort of more logical. So here we go. Cosine law again, solving for an angle. Again, press pause, drop that thing down, and when you try it, or if you need help, press pause and play for a little bit, and get going on it. So notice we have a side and an angle again. And so of course we are going to fill in information to this new pattern that we know. Okay, so we need to put the angle in this. We want to know it, so it has to be there, right, in order to solve for it. So that's B. And then way over on the other side is going to be the opposite side. So in this case, 12.3 goes in. It allows you to get that value. So what you're seeing here is that you have all of the sides, and that allows you to get an angle. So we're just getting B because it was asked for. We could get any angle. We want angle C, and we have the side C, the 9 over it. Anyway, so the 12.3, and then the other sides are 9 and 15. So, okay, this is the same triangle, right? So we solve for 12.3, right? And so we have the luxury of being able to say, hey, if I figure out based on the process we're doing that the angle's 55, we can say, hey, that worked. It's the right number. So 9, 15, all going to go in. And let's just run some numbers. So let's use this one that's, although this one times out on me, I have to grab the mouse and press it on here. Kind of like the way it works better. So 12.3 from the previous work. We're squaring that thing, getting 151.29. It's familiar, right? Just obviously this. Bad using the same numbers. See that we got the right answer, right? That 9 times 2 times 9 times 15. Let's do that again here just to make sure. So the 2 times the 9 times the 15. That's good. So there's your 270 number. And the cosine of B. So let's 225.81. Add that up again. Should just remember the numbers, but whatever. So there's 306 again. So this is another step where a very common error happens. Don't need that person. You can't subtract that right now. Okay, that's up there. No, good. Right. So instead, to work on solving for B, right? So what we can do is we can take away 306 from both sides. And again, we can't subtract 270 from 306 because it's not actually 270, it's 270 times cosine B, which is going to reduce the size. So subtracting 306 on both sides gives us how much here? We have 151.29. 151.29. Subtract the 306. Giving us 154.71 negative, right? So negative 154.71. And that is what negative 270 cos B is. Because we have then this multiplication by negative 270 to get rid of. So the 5 and negative 270 totally gets rid of that, leaving us with the rest of cos of B. And so we have to do that calculation over there, right? This thing here. Just going to calculate and become whatever this is, and then we're going to have to solve for B after that, right? So 1 by 270, and you times negative buttons, of course, right? So it's a positive answer. So positive answer 154.71. Hopefully it's still in there. Yay! Divided by 270. So that gives us negative 0.573. Oh, not negative, of course, because I just had the negative in there. We already said that. So 0.573. Good to all these things you're doing things, right? I looked at the calculator and had the negative, but because I didn't bother putting in the negative, right? 2 negatives make a positive. In reality, I didn't enter it in. So the calculator is spitting out a negative number because it doesn't know better. Anyways, so now to get rid of cosine, we know that. We've done that recently. So press pause, think about it, whatever, press play when you're ready. Cos inverse, I'll probably stop saying that soon. It's nice to remind people that of course you could. You can also slow the video down or speed it up, right, in YouTube. So if you need help doing that, let me know. There's a little gear, and YouTube open right now or not, the little gear in the video, and you can, so I can easily show that up anybody needs. Cos inverse of 0.573. So there's the 0.573 number. This is kind of one of the only times you would need a negative sign or negative button, is if you wanted to do it in here, you'd have to say a cos inverse, and I'd have to say like negative of that, so it's positive. Or I could just plug it in, right? So 0.573. Cos inverse of the 0.573 gives us 55 degrees. So there's 55 degrees that we started with. I don't know if you've ever seen victory slashes or not, but pretty common in math where you got the right answer and you got the answer you're hoping for. Full celebration, victory slashes, we call it. So that is it. Right? That's cosine law, where you're solving for a side, you're solving for an angle. Please give those a good try, showing lots of work, just like this kind of stuff, where you yes, right? You draw the triangle, and if you're doing on a separate page, especially this one, actually, you probably just do it on the page itself, you print it out or whatever. But show all the work, and yeah, there you go. That's it. If you have any questions, message me on D2L. It seems to be the better way of going about things. I have little folders, I keep track of who I've talked with, and yeah. Email me if you need anything, or message me on D2L. I should call it email. But all right, I'll stop rambling. We're done. See you later.